We now look at question 6 of the Further Statistics A-Level paper from 2024. In this question, we're given a random variable x, which has a certain probability generating function. In part A, we're asked to find variance x. Let's do this together. Probability generating function is quite an important topic in A-Level Further Statistics. But even if you've forgotten about it, you can actually get some hints from a formula book. Here I'm on page 23 of the formula book. Under statistics, it's given me some formulas, discrete distributions, and here the probability generating function of x, and then it actually tells me the formula for the variance. So that's going to come in handy. Based on what we just looked at, let's do part A together. The formula book actually gives us this formula, which is very useful. We simply need to differentiate the moment generating function. Let's write that in this way so it's easier for us to differentiate. Let's take the first derivative with respect to t. That's 4 minus 3t minus 3 over 2. And then we use chain rule to differentiate what's inside the bracket. Now that gives us this expression. And then the second derivative, let's take the derivative again. That's minus 9 over 4, 4 minus 3t to the 5 over 2. Differentiate what's within the brackets again, and we get minus 3. So we have 27 over 4 times 4 minus 3t to the power minus 5 over 2. So we work out g prime of 1, which is simply substituting into this expression. This expression here, put t equals 1, we get simply 3 over 2. And then g, and then square of that is 9 over 4. And then g double prime of 1, again looking at this expression here, substituting t equals 1, we get 27 over 4. Therefore, our variance of x using this formula is g double prime of 1, so that's 27 over 4, plus g prime of 1, that should be a plus, minus 3 over 2 squared. That gives me 6. So that's the variance of x. And that's our part A. Moving on to part B. It's asked us to evaluate the exact value of probability of x less than or equal to 2. Note the word exact there in the question. So we probably don't want to approximate our answer. If we could get a fraction, then we need to get a fraction. Let's see what we get. We could do it a long way, and let me show you how to do that to start with. We could use the series expansion for the probability generating function. For part B, we know that g equals 4 minus 3t to the power minus half. And let's express that in a form where we have 1 minus something. So let's take the 4 out, factorize by 4. And then, of course, we've taken 4 to the power minus a half out. 4 to the power minus a half is simply 1/2. So this is my series. And we want to do a series expansion. So keep the half, that's important to keep the 1 over 2 outside of the brackets. And we have 1 plus, let's use the index, minus 1 over 2, and keep the second term. So that's our second term. And then for the coefficient for t squared, we keep the 1 over 2. And then take that over 2 factorial. For this term, we'll need to take the square of this term, etc., etc. Okay? Simplifying 1 plus 3 over 8t. And then let's see what we have. So at the bottom we have 8 times 16. So that's 1 to 8. At the top we have 3 times 9. That's 27. T squared. Dot, 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 dot. And then multiplying the half into the brackets, plus 27 over 256 t squared, plus dot, dot, dot. And by definition, the coefficient or the constant term is p of x equals 0. The coefficient of term t is probability of x equals 1. The coefficient of t squared is probability of x equals 2. So to answer the question, p of x less than or equal to 2 equals p of x equals 0 plus p of x equals 1 plus p of x equals 2, which is a half plus 3 over 16 plus 27 over 256. And that gives us exactly 203 over 256. Make sure you don't write this as a decimal place because the question is asking for the exact value of the probability that x is less than or equal to 2. So that's our answer. I'm actually going to show you a way to do it a little bit quicker. Let's use the purple pen. We all know that probability of x less than or equal to 2, as we evaluated just now, is this probability. X equals 2, this one. And then because we have the probability generating function, the neat thing is that probability of x equals 0 is simply g of 0. Probability of x equals 1 is g prime 0. Probability of x equals 2 is g double prime 0. You can actually work this out by differentiating your probability generating function repeatedly and then putting 0 in place of t. So you can do that in your own time. But let's work out what G0 is. G0 is simply 1 over 2. So let's use red, 1 over 2. G prime of 0. So we've got G prime of 0, looking at this expression here. So G prime of 0 is going to be 3 over 2 times 4 to the power minus 3 over 2, okay? Which equals 3 over 16. We're going to look at this expression to work out G double prime evaluated at 0. So G double prime evaluated at 0 equals 27 over 4 times 4 to the power of 5 over 2 minus 5 over 2, and I get 27 over 256. So going back to my evaluation, so just now I saw this equals 3 over 16, so let me write that properly. 3 over 16, and that equals 27 over 256. So it's a much easier way to work out the probability of x less than or equal to 2, which is 1 over 2 plus 3 over 16 plus 27 over 256. Again, gives me exactly the same answer here. But we don't need to do the series expansion. So that was part B. We've got the exact value of probability of x less than or equal to 2. Now let's look at part C. Now we are told the independent random variables x1 and x2. So it's important for us to note that x1 and x2 are independent of each other. So we can use the properties of a probability generating function for independent variables. And we've been told that y equals x1 plus x2 plus 1. Part C, we are asked to find the probability generating function of y. State the name of the distribution of y. So that's a feature of probability generating functions. So probability generating function of y is simply probability generation function of t times probability generating function of t times t. That's a property of probability generating function. So let's multiply the terms together. And then t. So we get something like this over. And we are asked, so this is the probability generating function, and we're being asked. So we found the probability generating function of y. We also state the name of the distribution of y. We might not be familiar with this, but again, we've got help, which is our statistics table. So let's take a look at the discrete distributions here. So we've been given the PGF of known distributions. You might be spotting that the probability generating function of y is very similar to this one for a geometric distribution. So let's take a look. So this is in the form of pt over 1 minus pt. So let's see. We want it to be in the form of pt over 1 minus pt. So that's from our formula booklet. Can we convert this into this form? Maybe yes. We divide top and bottom by 4 so that this constant term is 1. That becomes 3 over 4. And 3 over 4 is conveniently 1 minus 1 over 4. So conveniently, we can say that y follows a geometric distribution with parameter 1 over 4. That's the name. If you want to write that out in full, that's geometric distribution. Okay. And then in part D, we are asked to find probability of x1 plus x2 greater than 5. Whenever the question says hence or otherwise, it's probably easier if we use the results from the previous part. We know that y equals x1 plus x2 plus 1, and we know that y follows a geometric distribution with parameter 1 over 4, and we're being asked to find p of x1 plus x2 greater than 5. So let's write that in terms of y. So x1 plus x2 is simply y minus 1. And so here we are asked, what's the probability that the number of attempts needed to get a success is greater than 6, which means that we want 6 failures. We know that y follows a geometric distribution. So this is simply asking us, what's the probability that we need to take more than 6 attempts to get a success, which means that we've got failures for 6 times. So the success rate is 1 over 4 failures, 1 minus 1 over 4. We want 6 failures. So simply we want 3 over 4 to the power 6, and we get 0.178, and that's our answer for part B.